Good morning. Today my topic of discussion is electrical conducting polymers. What are electrical conducting polymers? Or they are the material of the 21st century. Now electrical conducting polymers are the organic polymers that conduct electricity, and they are also called as synthetic metals. They combine the electrical properties of polymers with lighter weight, greater workability, and have vast scope of the applications. Now in 1950, researchers reported that the aromatic compounds form semiconducting charge transfer complexes salts with the halogens. Now in 1963, Bolto and co-workers reported conductivity in iodine doped polypyroles. In 1980, Dice and Logan reported films of polyaniline that could serve as electrodes. Now in 1977, Alan J. Hager, Alan McDiarmid, they reported high conductivity in oxidized iodine doped polyacetylene, and they earned 2000 Nobel Prize in Chemistry for the discovery and development of conducting polymers. Now, there is very sharp increase in the conductivity when intrinsically insulating organic conjugated polymers like polyethylene. They are doped with oxidizing or reducing agents. Now, what are the types of the dopants? There are mainly two types of dopants. First is electron acceptor and the second is electron donor. Generally, electron donors are alkali metals and electron acceptors are bromine, H2SO4, like that. Now, conjugated polymers in their undoped state, they are semiconductors or insulators, and the energy gap between them is too low. Now, what are the preparation methods of this electrical conducting polymer? Now, there are generally two types of methods. First is acetylene is bubbled through a solution of the catalyst and a solid polyacetylene precipitates they are formed. And the second method is acetylene gas is introduced into a glass tubes whose inner surface is coated with a catalyst, and then a layer of polyacetylene is formed at the surface of the catalyst. The amount formed from the acetylene to cis or trans, it depends upon the temperature. If you take 100 degrees Celsius temperature, trans structure are formed, and if you give a minus 80 degrees Celsius temperature, then cis structure is formed. Now there are few examples of electrical conducting polymers. First is polyacetylene. Polyacetylene has conductivity value of 10 to power minus 9 centimeter ohm inverse centimeter inverse for cis and 10 to power minus 5 ohm inverse centimeter inverse for transform. The value of conductivity is low because the pi electrons, they are not completely delocalized in the polyacetylene, and it has a band gap of 1.9 electron volt, but its conductivity can be enhanced by adding the impurity, or you can say that dopant. On adding a dopant, its conductivity increases as high as 10 to power 3 ohm inverse centimeter inverse in transform, and this is comparable to the metals that has been termed as synthetic metals. For that reason, we can say that electrical conducting polymers are called synthetic polymers. Now, the second example is polyparaphenylene. Polyparaphenylene is also consists of a long chain of the benzene ring and also it is a conductor, and it has been doped successfully to increase the electronic conductivity by doping with FeCl3, and the value obtained 0.3 ohm inverse centimeter inverse at room temperature. Now there are a few examples of electrical conducting polymer like polypyrrole, polythiopenes. Now the conditions for conducting polymers, there are conditions. First, more the conjugation, less is the energy gap and the conduction band. And second is it has electron releasing group and withdrawing group attached by conjugated polyacetylene, and the has more conjugation and conductance than polyethylene. Now what are the applications? There are few applications like in solid state batteries. They have light emitting diodes, artificial muscles, lightweight wires, electromagnetic shielding, and all this. Thank you.